Hi everybody. So in this video I'm going to show you how we use the scalar product equation with 3D vectors. This is where we have two vectors, a and b, and when you dot them together, this is equal to the magnitude of a multiplied by the magnitude of b multiplied by the cosine of the angle between them. And I'll show you what it means to dot two vectors together as we progress through the video. We can use this equation in lots of different ways when dealing with vectors. In example 1, we're told we have two lines, R1 given here and R2, and we've been asked to show that they are perpendicular. So if I draw a quick sketch of these two lines, so we have R1 given here and R2, and if they're perpendicular, then the angle between them, from this angle here, will be 90 degrees. And when we use the scalar product, the two vectors have to be moving away from this angle. And you can see it's the direction vector which is moving it away, not the position vector. So when we find a and b, we're using the direction of both vectors. So we're saying that a is equal to the direction vector of r1, and b would be the direction vector of r2. So now we have our a and b, we can substitute them into our equation. So we'll have vector a dotted with vector b will equal the magnitude of a times the magnitude of b times the cosine of the angle between them. And this is 90 because we've been asked to show that they're perpendicular. And we know the cos of 90 is 0, so that will make this entire right-hand side equal 0. So when we dot these two together, we should find that they equal 0. So we'll have the 6 lots of a 2 to give us 12, the 7 lots of a negative 1, minus 7, and the negative 5 lots of positive 1 to give us negative 5. And you can see that this does equal 0. So because we dot their two vectors together and we get 0, that means that this must be 90 degrees, because the cos of 90 is 0. Okay? So that's one of the ways you can show that two lines are perpendicular. In the next example, we're going to find the acute angle between two planes. Okay, so in this example, we're given that plane 1 has this equation, and plane 2 has this equation, both given in scalar product form. We've been asked to work out the acute angle between the two planes. So the first thing I'm going to do is I'm going to sketch a diagram. So we have our two planes. We know the perpendicular vector passing through plane 1 is 3, -2, -6. That's given here. And the perpendicular vector passing through plane 2 is -2, -1, 2. And that's given here. And to work out the acute angle between the two planes is to work out this angle here, which I'll call theta. And you can see that this is a right angle. So we'll call this alpha. And then we know that alpha plus theta will be 90 degrees. We also know that this angle is perpendicular, which means this one would also be theta. So to work out the angle between the two planes, we just need to work out the angle between the two normal vectors. And you can see that the scalar product allows us to do this. We've got the direction of our vectors, which is acting away from the angle. So if we say that vector A will be this one, and this will be vector B, then we can substitute each of these into this equation. So we've got A dotted with B will equal the magnitude of A multiplied by the magnitude of B times the cos of the angle theta. So we can work out the left-hand side. We've got -6 plus the 2, take away the 12, which gives us -16. And then we can Pythagorize each of these. So we get the square root of 49 multiplied by the square root of 9 times the cos of theta. We know this will be 7 times the 3, so we'll get negative 16 equals 21 cos theta. And then we'll take the arc cos of both sides. So we'll get theta is approximately 140 degrees to the nearest degree. But you can see that we were asked for the acute angle. So all we need to do is 180 take away 140, and this will give us theta is 40 degrees. Okay? So this is the acute angle between the two planes. I'll mark this on the diagram. Okay, so the next thing I want to show you is how we can use the scalar product to find the area of a triangle in 3D space. So in this example, we've been asked to find the area of the triangle OAB, which is this one here, where O is at the origin, and A has position vector 2i minus j plus 3k, and B has position vector 3i minus 2j minus k. So the way we're going to do this is if we find the angle here, theta, we know these two vectors are pointing away from that, so this will be vector A, and O to B will be vector B. And if we work out the magnitude of each of these vectors, then we can apply the area rule of a triangle. We know this will be the magnitude of A, this will be the magnitude of B, and this will be the angle between them. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we need to do is to work out the magnitude of this vector and this vector. So we'll Pythagorize each of these, and you can see that they're both root 14. So then we need to dot these two vectors together from this left-hand side. And this will help us work out the angle between the two vectors. So when we dot these two together, we'll get 6 plus the 2 minus the 3, which will give us 5. And then we'll substitute each of these into our equation. So we'll get 5 is equal to 14 cos theta. Dividing both sides by 14 and taking the arc cos, we can see that theta will be approximately 69 degrees. So at this point, we've got everything that we need. We've got this angle, 69. We've got the magnitude of A and B as root 14. So we'll substitute them into here. And we get approximately 6.54 units squared. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.